Hello, today we are going to go over calculating probability when you are given a condition. So it's called conditional probability. And basically what that means is instead of using like the true total, you're given a subset, and your new total then is going to be the subset that you're looking at. Okay. I feel like I made that sound way more complicated than it is. A lot of the times you're going to see the word given in there. So if we look at number 17, it says, in a class of students, the following data table summarizes how many students have a cat or a dog. What is the probability that a student has a dog given that they have a cat? So in this case, we know that they have a cat. Okay, that's our given. So we have to look only at the people that have a cat. Okay, because our given is that they have a cat. We know that. So if we look here, we have, 23 people who have a cat, right? And we want to know what's the probability that a student has a dog given that they have a cat. Well, 9 out of those 23 have a dog. Of course, you're going to go to your calculator and see if you can simplify your fraction. It doesn't specify how they want the answer, so that means that I would recommend doing a simplified fraction. So 9 over 23, and then to see if it simplifies, you do math on our enter. It doesn't simplify, so that is our answer there, 9/23. All right, so here in a class of students, the following data table summarizes how many students have a cat or a dog. What is the probability that a student who has a dog also has a cat? So in this case, they didn't use the word given, right? But they told us that we know that the student has a dog. We want to know what's the probability that they also have a cat. So we know they have a dog, and that's going to be 17 of our students here. And we want the probability that they also have a cat. So that's going to be 7 out of 17. Again, you would go to your calculator and see if you can simplify that. You cannot, so you're good. All right, now they're looking a little bit more complicated, right? It says the following table represents the highest educational attainment of all adult residents in a certain town. If a resident who has completed just high school or only some college is chosen at random. So in this case, it says we are looking at just high school or only some college. So high school only or only some college. What's the probability that they are aged 30 to 49? So, again, we are only looking at people who have completed high school and some college. So our total is going to be the total number of people that have completed high school and or some college. So that would be 4653, plus 5622. So our total here is going to be 10,275. And we want to know the probability that they are aged 30 to 49. So again, we're only looking at this subset. And 30 to 49 is going to be anyone in these categories here. So we need to find the total number of people that fall into that category, which is going to be 942, 1065, 585, and 684. So that's 3,276. Now it says round your answer to the nearest thousandth. So they do not want a simplified fraction here. They want a decimal. So we're just going to divide on our calculator here. And I'm just going to write out the big decimal, and then we'll talk about the rounding. So it says thousandth. That is 3 decimal places because it goes tenth, hundredth, thousandth. So we would cut it off right here. This 8 tells this 8 to get bumped up. So our answer here is going to be 0.319. That's a tricky one. There's a lot of words there, and you have to read it very carefully. So let's try another one. It says the following table represents the highest educational attainment of all adult residents in a certain town. If an adult is chosen randomly from the town, what is the probability that they have a high school degree or some college, but no college degree? Okay, so in this case, our total actually is going to be the total here, right? It says if an adult is chosen randomly from the town, okay? So it's not like we're only looking here, like where it says if a resident has completed high school, some college. No, we're looking randomly out of the entire town. So our total is in fact going to be the 15368 that they give us here. What is the probability that they have a high school degree or some college, but no college degree? So that's going to be these guys. All right. High school degree, some college. Now, a bachelor's degree is a college degree, and a master's degree is also like a college degree. So we wouldn't count those, right? So we have to add up the total number of people that have high school or some college, which is going to be 2811. Oh my goodness. And 5581. And then that gives us what, 8,392. And then we're going to divide that by the total number of people in this town here, which is 15368. And again, they said to round to the nearest thousandth here. So that's going to be 3 decimal places. So we've got 0.54606. Here we cut it out. The 0 tells me to keep the 6 the same here. So I get 0.546. Your rounding is going to be very important, so make sure you pay attention to that. All right, and then let's see. Similar problem here. And it says, if a resident who is age 20 to 29 is chosen at random. So again, we're not, in this case, now we're back to only looking at a subset. It says if a resident who is age 20 to 29 is chosen at random. So we are only looking at age 20 to 29. So that's going to be our total, okay? So our total is going to be 5,360. What is the probability that they have only completed high school? So that's this, 1296. And the nearest thousandth again, so we're going to do 1296. Why does it keep putting an L1 in there? 1296 divided by 5360. And they want rounded to the nearest thousandth. So if I have 0.24179, this rounds my 1 up to a 2, so I get 0.242. All right. So it says, now these kind of problems always trip people up because what they'll do is they'll try and add everything together, and then the total that they calculate ends up being more than the total in the class. And the reason for that is these numbers that you're given, you can essentially make one of those two-way tables out of. And if you're just adding up all the numbers, you're going to be double counting some people. So you kind of have to take that into account. So it says in a class of 22 students, 13 play an instrument and 17 play a sport. There are 5 students who play an instrument and also play a sport. What is the probability that a student does not play a sport given that they play an instrument? So first off, we got that word given in there. We know it's going to be a conditional probability. So we're going to go ahead. And what I recommend doing in this kind of scenario where you have like scenarios where like 2 things are going on, right? Like we're looking at instrument and playing a sport. I recommend making a two-way table. So we're going to do this. Let's see. How many little bars do I want here? 1, 2, 3, 4. Okay, so I want a 4x4. Make our fun little two-way table. I feel like I'm putting way more time into this than I really should be. It's not that deep. Okay, so we have an instrument and no instrument, right? And then we have a sport. And no sport. And then, of course, we have our totals, right? So they told us that the class has 22 students. So that's going to be like our grand total here, right? We know that out of those 22, 13 play an instrument. So we've got 13 playing an instrument and 7 play a sport. So our total for sport is going to be 17. There are 5 students who play an instrument and also play a sport. So instrument and sport is going to be 5. Now it says, what's the probability that a student does not play a sport given that they play an instrument? So we know that they play an instrument, okay? So we are only looking at the people who play instruments. So that's going to be out of 13, right? Now you could go and completely fill in all of these boxes here, but you don't necessarily need to do that. In this case, our given is that they play an instrument. We want to know the probability that they do not play a sport. So we essentially just need to find this missing piece here, which you would do 13 minus 5. That means you're going to have 8 people that do not play a sport. So we do 8 out of the 13, okay? And of course, you're going to go ahead and see if you can simplify that, right? Can you simplify, 8 over 13 on your calculator? You cannot. Now, this one does not specify if they want it as a decimal or if they want it as a fraction. So remember, when they don't specify, I would just give it as a reduced fraction. Our answer is going to be 8/13 here. All right, let's try another one here. So it says, in a class of 25 students, 7 are female and 16 have an A in the class. There are 7 students who are male and do not have an A in the class. What is the probability that a student has an A, given that the student is a female? So similar kind of problem going on here. You know what I'll do to save everyone time here? I'm just going to copy paste this little thing, and so go ahead and make another table. Obviously it's going to have different topics here, but look at that. And then I can just go and erase all my little information. All right. So in this case, our total here is going to be the 25 students, right? Why is it not? There we go. And we're looking at female versus male, and an A and no A. So we have 7 students who are female. 16 have an A in the class. There are 7 who are male and do not have an A. So male and no A is going to be 7. What is the probability that a student has an A given that the student is a female? So our given is that the student is a female. So we know that it's going to be out of 7 because there are 7 females in the class. However, we do not know right now how many of those females have an A, right? So what we can go ahead and do is kind of what I would recommend in this scenario is just start filling in boxes based on the information that you have. And eventually, right, we will figure out what we need here, which is going to be how many of our female students have an A, right? So let's see. We know we've got 25 students in the class. So I would do 25 minus 16. And I've got 9 here. So then I can figure out that 2 of the no A students are going to be, 2 of the no A students are going to be female. And then from there, I can figure out that 5 of my female students have A's. So what is the probability that a student has an A given that the student's a female? We know they're a female, and 5 of those females have an A. So that would be 5/7. All right, so remember, whenever you get these kind of scenarios going on where you have overlapping things, right? Like we have 2 things going on, right? We're looking at female versus male, A versus no A. So these numbers are going to fall into 2 categories. So that's why you're going to want to make this 2-way table so you can properly get your probabilities there.